The first kind of function that we're looking at is this nested for loop. So we see that our outer for loop runs from 0 to n, and our inner for loop runs from 0 to I, where I is the iterator for our outer for loop. So our inner loop depends on our outer loop. Inside our inner loop, we see we have this constant time operation. So we can actually express this loop, these nested for loops, as a double summation. So we see that this rightmost summation reflects our inner for loop, and this leftmost summation reflects our outer for loop. So we're summing from 0 to n minus 1 for I, and we're summing from 0 to I minus 1 for j. And this 1 represents this constant time operation that we do. So this summation that we have from the previous slide is actually equivalent to this summation right here, because if we sum from 0 to I minus 1 of 1, this whole value is actually just going to equal to I. So when we actually expand out this new summation over here, we get that it's just 0 plus 1 plus 2 plus all the way to n minus 1. And this is equivalent to n times n minus 1 over 2 in a closed form. And we know this because of Gauss's identity. So the possible runtime for our nested for loops is actually going to be that t of n equals n times n minus 1 over 2. And if we further expand that, we get that it's 1/2 n squared minus 1/2 n. So when we apply our analysis onto t of n, we get that t of n is in theta of n squared. We know this because the n squared term dominates our n, and we can drop off the 1/2 constant, because as n goes to infinity, that constant doesn't really matter in the end runtime.